Right now, 4.6 billion years old, our sun is quietly dying. Not today, not tomorrow, but the process has already started. And when it finally ends, everything you've ever known, every mountain, every ocean, every trace that humanity ever existed, will be gone. But here's what nobody tells you. The way it dies, it's so much stranger than you think. So let's start with what the sun actually is. It's not burning, not like a campfire. There's no oxygen in space for that. What it's doing is something way more violent. It's fusing hydrogen atoms together in its core, smashing them so hard they become helium. And that process releases an insane amount of energy. That energy is what we feel as sunlight. That's what keeps us alive. But here's the catch. The sun has a finite amount of hydrogen, and every single second, it burns through 600 million tons of it. Right now, we're in what scientists call the main sequence phase. This is the stable era. The sun is balanced, gravity pulling inward, fusion pressure pushing outward. It's been like this for 4.6 billion years. It'll stay like this for another 5 billion. But then, the hydrogen runs out. This is where things get weird, and honestly, a little terrifying. When the hydrogen in the core is exhausted, gravity wins. The core starts to collapse inward under its own weight, and that collapse generates heat. Enormous heat. So much heat that the hydrogen in the outer shell, which still has plenty of fuel, ignites. The sun doesn't go out, it expands. This is the red giant phase, and it is brutal. The sun will grow to roughly 200 times its current size. Its outer edge will swallow Mercury, then Venus. Then, well, there's a debate about Earth. Some models say we get swallowed whole. Others say we escape, barely, as the sun loses mass and our orbit shifts outward. Either way, the oceans boil off in 1 billion years before that even happens. Earth becomes a scorched rock long before the sun engulfs it. But here's what I find genuinely unsettling. We talk about this like it's far away, and in human terms, it is. 5 billion years is incomprehensible. But the universe is 13.8 billion years old. The sun has already lived a third of its life. If you compressed the sun's entire lifespan into 1 year, we're already in July. Okay, back to the death sequence. So the sun has expanded into a red giant. Earth is gone, or barely hanging on as a charred cinder. What happens next? The core is still collapsing. Temperatures keep climbing. And eventually, they reach the threshold where helium starts to fuse. This is called the helium flash, and it happens in a matter of minutes. The sun briefly stabilizes. It's smaller, hotter, blue-white, a different kind of star. This phase lasts about 1 billion years. Then the helium runs out. And this time, there's no next fuel. Our sun isn't massive enough to fuse carbon. It's not like the giant stars that keep going, layer after layer, until they explode as supernovas. Our sun just stops. What you're watching, that's called a planetary nebula. Not because it has anything to do with planets. Astronomers just used to think they looked like planets through early telescopes. What it actually is, the sun's outer shell, ejected into space. A cloud of glowing gas, hydrogen, helium, oxygen, carbon. And in the middle of all that, a tiny, dense, white-hot object, the core, compressed to roughly the size of Earth. That's called a white dwarf. The white dwarf is the sun's corpse. It's not fusing anything, no nuclear reactions. It's just slowly radiating away the heat it already has. It'll take trillions of years to fully cool down. In the far, far future, we're talking something like 10 to the power of 15 years from now, it becomes something called a black dwarf. A cold, dark, dead remnant of a star, drifting silently through space. Here's the kicker, though. No black dwarf has ever been observed. Not one. Not anywhere in the universe, because the universe isn't old enough yet. The oldest white dwarfs we can see have been cooling for about 10 billion years. They're still white, still glowing faintly. A true black dwarf requires more time than the current age of the universe, times 100,000. So in a very real sense, we've never seen what the sun will ultimately become. And that's what gets me. We know the life cycle. We can calculate every phase. We can predict the exact mechanisms. But the final form of our sun, the black dwarf, exists only in mathematics. No one has ever seen one. No civilization ever will. The universe is physically too young. It's a prediction about a future so distant, it's almost meaningless to say the number out loud. Our sun, right now, is in its prime. It will be stable for another 5 billion years. That's more time than life on Earth has existed, twice over. But it is mortal.